two laws of indices. What are they? I will explain you on the board. There are two laws of indices we discussed up to now. What are they? A to the power m multiplied by a to the power n. When multiplying same bases, indices should be added. A to the power m plus n. When we are dividing same bases, a to the power m division a to the power n. When we are dividing same bases, indices should be subtracted. Those laws of indices we discussed up to now. Now, shall we apply these two laws of indices in solving these kind of questions? What should be the answer for this? A to the power 5 divided by a to the power 3. What happened? When dividing, we told you that when dividing same bases, indices should be subtracted. So a to the power m, a to the power here given a to the power 5 divided by a to the power 3. When dividing same bases, indices should be subtracted. No? Then a to the power 5 minus 3. It is a to the power 2. Right? Here then the second example, x to the power 7 divided by x to the power 2. When dividing same bases, indices should be subtracted. Then x to the power 5. Let's take the third question. This is first question, second question, third question. X to the power 2, x to the power 8 divided by x to the power 3. When dividing same bases, indices should be subtracted. But here 2 is there. X to the power 8. X to the power 8 subtract 3. Then it is 2 x to the power 5. Then the fourth question, 4 p to the power 6 division 2p to the power 3 equals 4 p to the power 6 divided by 2 p to the power 3 equals 4 divided by 2, it is 2. P to the power 6 minus 3. When dividing same bases, indices should be subtracted. Then the answer is 2 p to the power 3. 2 p to the power 3. Can you write it down? Fifth question, 10 m to the power 5 divided by 2 m to the power 2. Then 10 divided by 2, it is 5 m 5 minus 2. Then it is 5 m to the power 3. When dividing, indices should be subtracted. Sixth question, x to the power 2 multiplied by x to the power 4 divided by x to the power 3. When multiplying same bases, indices should be added. And when dividing, indices should be subtracted. 3 should be subtracted. These two should be added. These two indices should be added. Then x to the 6 minus 3, 3. X to the power 3. Seventh question, n to the power 5 divided by n to the power 2 multiplied by n. Here, if there is nothing, you can take it as n to the power 1, right? Then n to the power 5 divided by, according to the laws of indices, you should add when multiplying same bases, n to the power 3. According to the laws of indices, when dividing same bases, indices should be subtracted. 5 minus 3 then n to the power 2 is the answer. If you do the third, then eighth question, 2x to the power 3 multiplied by 2x divided by 4x equals, then 2, 2 times 2, 2 times 2 is 4, x to the power 3, x to the power 1, that is x to the power 4 divided by 4 x to the power 1. 4 to 4 can be cancelled out. Then it is x to the power 4 minus 1 according to laws of indices. When dividing same bases, indices should be subtracted like this. Then it is x to the power 3. Right? Then let's move to the ninth question. X to the power, this is ninth question, x to the power 5 multiplied by x to the power 2 multiplied by 2x to the power 6 divided by x to the power 7 multiplied by x to the power 2. Here, when you are multiplying, 2 is there, 2 times 1 times 2, 2. Here, 2 times 1 times 1, 2, 2. X to the power 5 added 2 add 6. When multiplying, same bases, indices should be added according to the laws of indices. Here also multiplication, therefore you add them, it is 9. Or you can say that 2 plus 7. Then it is 2 x to the power 7 plus 6, 13 divided by x to the power 9. That is 2 x to the power 13 minus 9, because when we are dividing, indices should be subtracted. That is 2 x to the power 4. Shall we move to the 10th question? A to the power 5 times b to the power 3 divided by a to the power 2 times b to the power 2. You can apply laws of indices if they are in same base. Here a to the power 5, here a to the power 2. Then when dividing these two, you should subtract 2 from 5. If you consider base b, 3 to the 3 minus 2 then the answer is a to the power 3, b to the power 1, that is b. You can keep like this. Then let's move to the last question, 11th question. 2p to the power 4 multiplied by 2p to the power 3 divided by p times q. Here this is q. Then 2 times 2, it is 4. P, here 1, therefore 4 minus 1. Q is there, here 1, therefore 3 minus 1. Then the answer is 4 P 3 Q to the power 2. 4p to the power 3 q to the power 2. Okay, if I explain you again, the eighth question. The eighth question, 2p to the power negative 2, 2p to the power 3, 2p to the power 4. 2p, negative 2, addition 3, subtract 4. Denominator, when we are dividing, it should be subtracted. These two should be added. These two indices should be added. Right? They added. Then 4 should be subtracted. Negative 2 addition positive 3 is negative 1. No, negative 2 addition positive 3 is positive 1. Positive 1 addition negative 4 is negative 3. Negative 2 addition positive 3 is positive 1. Positive 1 addition negative 4 is negative 3. Since this is with negative index, you should convert it into a positive index by taking it into denominator. Now it is positive. 2 to the power 3 is 8. P to the power 3 is P to the power 3 is 1 upon 8 P to the power 3. When we're talking about negative indices, if we take an example for this, x to the power 5 divided by x to the power 3, then if you expand this, x times x times x times x times x, that should be 5x's divided by x to the power 3 means x times x times x, then x to x, 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 x cancel. The answer is x to the power 2. Right? Same way, if you put here x to the power 3 and upon x to the power 5, right? Right? What happened? There is a problem. Let's see what happened. If I erase this, right? If I take x to the power 2 upon x to the power 5, to find the solution, I will use this expanding method, and the law of indices. If you use expanding method for this, let's expand this. X to the power 2 means x times x upon x to the power 5 means x times x times x times x, x, then cancel 1, 1x, 1n, 1x. Then the answer is 1 upon x to the power 3. Right? If you use this method, right, law of indices, by applying laws of indices to find the answer for this one, what happened? Let's see. X to the power 2 minus 5. Then it is x to the power negative 2 minus 5 is negative 3. These two answers should be same, no? This one, so we did the same question, right? But we are getting different answers. No, you can't get different answers for the same question. That means these two should be equal. You can say that x to the power negative 3 is equal to this answer, x1 upon x to the power 3. X to the power negative 3 should be equal to 1 upon x to the power 3. That means in generally, you can say that x to the power negative m, if there is negative power, you can take it into the denominator place, x to the power m, by converting the index into a positive value, right? You should remember this, right? When there is a negative power, you can change the position, numerator denominator position, and convert it into a positive index, right? Can you write this down? Not only like that, we can write this same negative, converting negative index into a positive way like this. If there is a negative index in numerator, right, this is a numerator number, right, it can be converted into a positive index by taking it into denominator place. And here, if it is given as like this, a to the power negative m, now the negative index power is in denominator place, you can convert it into a positive index by taking the denominator place base into power into the numerator place. Right now it has been changed into positive. This is now a positive index. Right? Basically, what we should do, you interchange the numerator denominator position to convert the negative into positive. Right? And another way, if there are two negative indices, if there are two powers having negative indices, you take this numerator number to the denominator place by converting it to a positive index. You take this denominator number into a positive index by taking it the into this numerator place. So you should remember these things as well. Converting negative converting negative indices to positive indices. Right? Write down these things. Example number 1. Evaluate the following. 2 to the power negative 5. Here you have to convert it into a positive index first, because you can't find the value of a negative index power. So you convert it into a power of positive index. Now what we should do, 2 to the power negative 5, according to this law of indices, you convert it into a positive index power by taking it into a denominator place. Then now it is 1 upon 2 to the power 5. 2 to the power 5 means 2 times 2 times 2 times 2 times 2. There should be 5 2's multiplying together. Then that is 32. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. So 1 upon 32 is the answer. Let's take the second example. This one, right? Here what we should do. 1 upon 5 to the power negative 2 is there. You have to convert it into a positive index. Use this law of index, right? It is in denominator place. Here 5 to the power negative 2. So you take it into the numerator place by converting this negative index to a positive. 5 to the power 2. 5 to the power 2 is 25. 5 to the power 2 is 25. Right? Is it clear? These are some. Here you can take this negative index power into numerator by convert it into a positive index, right? And here negative 4 come into this place. Here x is positive 1, and when multiplying it becomes x to the power 5. 2x to the power 5 then. Negative 4 comes here as positive 4. 1 plus 4 together, it becomes 5. Here, a is there in numerator, but the term having negative power is this p to the power negative 3. You should take it into the numerator place by converting it to a positive power. Then it becomes b to the power 3 upon 2. Right. Now we are going to do the 10th question. M is already a positive power, m to the power 1, right? But this term is having a negative index, therefore you should take it into numerator place, converting it to a positive index. Now it is a positive. We can further simplify this one. 2 to the power 2 is 4. M and n has to be powered to 2, therefore n square. 4mn square. Let's move to this question. 11th question. Only the negative term is t to the power negative 2 side, having a negative index. So you have to convert, you have to take it into denominator. M is already in denominator, it doesn't change, but t has taken to denominator place by converting into a positive index. Here nothing is there. If nothing, you can put t1 here. T to the power negative 2 has been taken into the denominator place as t to the power 2. According to the laws of indices, you should take q to the power negative 2 to the numerator place, converting it to a positive index, then it becomes q to the power 2. P is already there, therefore P should be like this. You have to convert this 13th one to a positive term having positive indices. So x to the power 2, negative 2, yes, there. Therefore, you should take it here to denominator place. Denominator position should be changed. Then it becomes positive. Here, y to the power negative 2 is in denominator place. You take it to the numerator place, converting it to a positive index like this. Let's move to the 14th question. Both these are having negative. So you just take the reciprocal. Then this become 3y, no? 3y upon 2x all the set. Now you have interchange, numerator to denominator position. Then the sign of this index should be changed to positive, from negative to positive. Now let's move to the second question. 2 to the power negative 2. 2 to the power negative 2. Evaluate the following. Evaluate means you have to find the value. That should be taken into denominator place. Then it becomes 1 upon 2 to the power 2. Right, this is 2. Then it is equal to 1 upon 2 to the power 2 is 4. Convert this negative power into positive index, and then you can find the value. Here, the power which is having negative index is in denominator place. According to the laws of indices, you should take it into numerator place by converting this into a positive index like this. Now you can find the value, because you can't find the value of a negative index power, but here this power is having a positive index. So 4 to the power 2 is 4 times 4. It is 16. 16. 4 to the power 2 is 16. Here 2 to the power negative 7. It can be converted into a positive index by taking it into the denominator place. Then it is 2 to the power 7. Evaluate means you have to find the value of 2 to the power 7 as well. 1 upon 128. 2 to the power 7 means you have to multiply 7 2's together. 1 upon 128. 2 to the power 7 is 128. Let's do the fourth question. Negative 4 to the power negative 3. It should be converted into a positive power by taking it into the denominator place. Negative 4 is the base. Don't change the base, but you should change the index. It should be converted into positive. Now it is 1 upon negative 4 to the power 3. It is equal to 1 upon negative 4 to the power 3. What is the value of negative 4 to the power 3? Negative 4 to the power 3 means negative 4 times negative 4 times negative 4. 4 times 4, 16. 16 times 4, 64. Negative, negative, positive, positive, negative, negative. Therefore, answer is negative 64. That is the value of negative 4 to the power 3. So you can substitute that value here as negative 64. That means 1 upon negative 1 upon 64. Let's do the fifth question. Should be converted into a positive index. That is 1 upon 3 to the power 2. Right? Then it is equal to 1 upon 3 to the power 2 is 9. Let's do the sixth question. 5 times, you should take this negative power to the positive, taking it into numerator, then it becomes 5 to the power 2. Then this is 1, just 5 is 5 to the power 1. When multiplying same bases, according to the laws of indices, these indices should be added. Then it should be 5 to the power 1 plus 2 is 3. 5 to the power 3 is 5 times 5 times 5. 5 times 5, 25. 25 times 5, 125. Let's do this seventh question. It should be 1 upon 10 to the power 3. 1 upon 10 to the power 3 is equal to 1 upon 10 to the power 3 is 10 to the power 3 is 1000. 1 upon 1000. Let's do this eighth question. Here both are having negative powers, so you should convert them into positive indices by taking the reciprocal. Both should be interchanged. Then 5 to the power 2 comes here into numerator place. 3 to the power negative 2 should be taken into the denominator place. Now it becomes 3 to the power 2 here in denominator place. Change the sign. Now 4 to the power 2 is 16. 3 to the power 2 is 9. But this is an improper fraction. Better to give it as a mixed number. How many 9s are there for 16? Only 1. 7 remains. out of 9. That should be the answer. I will give 1 minute to write it down. These are the solutions for the first 5 questions, right? Then we are going to do the 6th question. This question is 10x to the power negative 5 upon 5x to the power 2. 5 and 10 both are divisible by 5. 5 divided by 5, 1. 10 divided by 5, 2. 2x to the power negative 5. When dividing, this should be subtracted. 2 should be subtracted. That is 2x to the power negative 7. Negative 5 and negative 2, it becomes negative 7. You should give the answer in positive indexes, with positive indices. Therefore, you should take x to the power 7 to the denominator place. Then 2 upon x to the power 7. Let's move to the 7th question. 4x to the power negative 3 times x to the power negative 5 divided by 2x to the power 2. That is 4x to the power negative 3 and negative 5 should be added. Negative 8 and divided by 2 to x to the power 2. 2 and 4 can be cancelled out. Both are divisible by 2. 4 divided by 2, 2. 2 divided by 2, 1. Then it is 2 x to the power negative 8 minus 2. X 2 should be subtracted. That means 2 x to the power negative 10, but it is having negative index. So we should give the answer with positive indices. So 2 upon x should be taken to the denominator place. Convert it into a positive index. Write them down. X to the power 5 divided by x to the power 5. Then, when dividing same base, indices should be subtracted. So 5 should be subtracted from 5. 5 minus 5 is 0. It is 0. Then regarding the 0 index, we are getting here 0. By applying laws of indices, you get this one as 0. If you use the expanding method and simplify it, x to the power 5 divided by x to the power 5 is equal to x to the power 5 expanded divided by x to the power 5 again expanded. X to x cancel, right? You can cancel them like this. X here, x to x cancel, x to x cancel, x to x cancel. Numerator denominator can be cancelled now. All the x's are cancelled. Only one here, only one. All are ones, no? One, here, one, here, one. You get to all one. Here, one, 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 one. 1 upon 1. 1 times 1 times 1 times 1 is 1 upon 1 times 1 times 1 times 1 is 1. 1 upon 1 is 1. Oh, you hear? If you use this method, that means laws of indices to simplify this question, right? This one, you are getting s to the power 5 as the answer. If you use the expanding method and simplification method, then you will get 1 as the answer. They should be equal because you are doing the same question, no? Right? They should be equal. You should not get different answers. Although you followed say different methods, you should get the same answers. That gives the implication. That implies that x to the power 0 is equal to 1, where x is any number except 0. X can't be 0 here, right? That is the condition, right? Where x is any number except 0, right? So can you write this down? Very important thing here is this. I will highlight it using the red color like this. This is the important thing. Can you write it in your writing book as a note? X to the power 0 is equal to 1, where x is any number except 0. Let's move to the fourth question. Y to the power 4 times y to the power 2. It is y to the power 6 divided by y to the power 6. Right? When multiplying same bases, integer should be added. But here, when you are dividing, integer should be subtracted. Therefore, it becomes y to the power 0. 6 subtract 6. Y to the power 0, any number except 0 to the power 1 to the power 0 is 1. Therefore, the answer is 1. Let's move to this one. P to the power 3 plus 5 plus, if you hear nothing, you can consider it as 1. P to the power 1 is there. 3 plus 5 plus 1. Then 6 plus 6, 9. Then P to the power 9. When multiplying same bases, integers should be added. P. Here, P to the power 9. Because 3 and 6 should be added. 9. Then when dividing, indices should be subtracted. Therefore, it is p to the power 0. 9 subtract 9. It is 0. P to the power 0 is what? You learn that according to the laws of indices, any number except 0 to the power 0 is 1. Therefore, the answer is 1. Let's move to the sixth question. X to the power -2, x to the power -4, and x to the power x to the power 6 positive. -2 and -4 adding -6. -6 addition +6, it becomes x to the power 0 in numerator. Because when we are multiplying same bases, integer should be added. -2 and -4 should be added. -6. -6 and +6, x to the power 0. Here, if you add this -2 and +8, +6. -2 addition +8, +6. +6 addition -6, again 0. Then it is y to the power 0. Both are y to the power 0. X to the power 0 is 1. Y to the power 0 is 1. 1 upon 1, answer is 1. Let's move to the second question. Any number to the power 0, it is 1. Any number except 0 to the power 0 is 1. Therefore, this value is 1. 1. Here 1 is there, plus 1. 1 plus 1, it is what? It is 2. 1 plus 1, it is 2. The answer is 2 there. Here, no need to simplify. Any number except 0 to the power 0 is 1. Here, this is 1. 5 to the power 0 is 1. Plus 1. 1 plus 1 is 2. Here, no need to simplify. Any number except 0 to the power 0 is 1, according to the laws of indices. This number is 1. This is power to 0, no? 1. Minus 2 to the power 0, again 1. 1 minus 1, what? 1 minus 1 is 0. Here, any number, any value except 0 to the power 0 is 1 according to the laws of indices. Therefore, this should be 1. Remember that when there is a power of a power, like this, a to the power m n, then a to the power m times n or mn, power of power. Let's discuss this example. Number 1, a to the power 5 2 times a to the power 5 to the power 2. Then that means if there is power of power, you should multiply these 5 and 2. These two indices should be multiplied. 5 times 2 like this. Then it is 5 to a to the power 10. 5 times 2 is 10. A times a. A is a to the power 1. Then when we are multiplying same bases, indices should be added. 10 plus 1, 11. Here you use this law of indices. When there is a power of power, you should multiply these two indices and get the result. Like this, right? Here the power of power is 5 to a to the power 5 times a to the power 5 to the power 2. Power of power. Here let's move to the second. P to the power 3 4 times a to x to the power 2 to the power 0. Then there is 2 power to the power of power. So 3 to the power 4, here 3 times 4, x to the power 2 to the power 0 is 0, 2 times 2 is 0, then 2 times 0 is 0, 3 times 4 is 12, then p to the power 12, x to the power 0, according to the laws of indices, any number except 0 to the power 0 is 1, yeah, then again, if you're multiplying by 1, this doesn't change, then the answer is p to the power 12. This one, 2 to the power x to the power 2 to x y to the power 3 to the power 2. Here, all the sets you should take 2. Therefore, each term you have to take to the power 2. 2 to the power 2 is 2 to the power 2. Here, x to the power 2, 2 is x to the power 4. Y to the power 3 to the power 2 is 3 times 2, 6. Then 2 to the power 2 is 4, x 4, y 4, y 6. 4, x 4, y 6. Here 5 to the power 2 times negative 1. That means 5 to the power negative 2, right? Addition 1 upon 5. Then it is here 5 to the power negative 2. That should be converted into a positive index upon 1 upon 5 to the power 2. 5 to the power 2 is 25. Right? Addition 1 upon 5. Then that is, you have to take the common denominator as 25. 25. 1 here. Let's take the common denominator as 25. So you should multiply this one by 5. According to equivalent fraction knowledge, you should multiply the numerator as well by 5 if you are multiplying the denominator by 5. Then it is 5 times 1. 5 times 1 is 5. Then the answer is 5 plus 1, 6. 6 upon 25. 6 upon 25. Let's move to the fifth question. 4 to the power 0. Any number except 0 to the power 0 is 1. 1 to the power 2 then multiply by 1. 4 to the power 0 is 1. Then 1 to the power 0 is 1. Oh, sorry, 1 to the power 2 is 1. 1 times 1, 1. Then 1 times 1 again, 1. Answer is 1. Here 10 to the power 2 to the power 2. Power for power. You learn according to the laws of indices. When there is a power of power, you should multiply these two indices. 4 to the power 10 to the power 4 there. 10 to the power 4. 2 times 2 is 4. 10 to the power 4 is 10,000. Having 4 zeros, 10,000. Let's move to the eighth question. Here, since there is a negative index as a power, and here also negative index, when there is a power of power, according to the laws of indices, these two indices should be multiplied. Negative 2 times negative 4 is 8. It is 8. Negative into negative, positive. P to the power 8. If I explain you again, first one, if there are two powers, power for power, then you should multiply these two indices, x to the power 12. 3 times 4, 12. According to the laws of indices, these two indices should be multiplied together if there is a power for power. Here, these two should be multiplied power for power, negative 2 times 2, negative 4. You should convert it into a positive index because the question is given us as instruction to express using positive indices. So this one should be converted into positive index 1 upon p to the power 4. You know, according to the laws of indices, a negative index can be converted into a positive index by taking it into the denominator place. Here, power of power, a to the power 4, a to the power 4. Both of these two should be multiplied by 2. Here, power of power, 2 to the power 3. This number also should be taken to the power 3. X to the power 2 to the power 3, that is x to the power 6. Then 2 to the power 3 is 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 x to the power 6. Then x to the power 5, x to the power 15, power, x to the power 2 also to be taken to the power 3, then x to the power 6. According to laws of indices, power for power, a to the power 2 is a to the power 3 to the power 2 is a to the power 6. B to the power 2 to the power 2 is a to b to the power 2, b to the power 4, then 2 times 2. Here there is a negative index. You have to convert it into a positive index by taking the reciprocal of this, right? Interchange the position. N to the power 2 comes to the numerator place. This one, which is in numerator place, should be taken into the denominator place. Then once you have done that one, you have to convert this negative index to the power positive index, positive 2. Then when we are taking power of power, n to the power 2 to the power 2 is n to the power 4, m to the power 3 to the power 2 is m to the power 6. Okay, that means n to the power 4 upon m to the power 6. Here, power of power, if you apply law of indices, when there is a power of power, you should multiply these two indices. Negative 2 to the power negative 4, negative 2 times negative 4, positive 8. P to the 1, positive 8. This is already positive index, therefore no need to change. Do these miscellaneous exercise questions at home, right? If you have any questions, you can ask from me. Do these questions at home. Let's move to the summary of this lesson, right? This is a summary of this lesson. If I recall you what we have learned in this lesson, you can write this one as well. A to the power m times a to the power m. When multiplying same bases, indices should be added. A to the power m divided by a to the power n. When dividing same bases are same, a. Remember that if you are applying both of these two laws of indices, bases should be same, right? If bases are same only, you can apply these two laws. So these two laws can be applied if bases are same. A to the power m divided by a to the power n. When dividing same bases, indices should be subtracted. M subtract n. This value should be subtracted from this initial value, right? Then if there is a negative, if there is positive index, that can be converted into a negative index by taking it into the denominator place. Basically, what we have learned in this is, if you are changing the placement, numerator, denominator placement, then the sign of this index should be changed. Right? When there is a power of a power, you should multiply two indices, right? A to the power m to the power n, power of a power, then two indices should be multiplied, mn. If x is not equal to 0, then you can apply x to the power 0. Any number except 0 to the power 0, it is 1. It is equal to 1, right? And also I will add one more. if x to the power 1, x to the power 1, any number to the power 1 is the number itself. It is what? It is x, the number itself. Any number to the power 1, it is the number itself. For an example, if there is 2 to the power 1, it is 2. If it is 2 is there, then you can take it as 2 to the power 1. You may remember that we have taken this one sometimes. If there is nothing as a power, you can take it as 1 as the power index, right? So that's all for this lesson. Thank you for your participation.